The Sahara Desert sits on top of something that should not exist. Buried beneath its dunes, in some places stretching hundreds of feet straight down, are salt deposits so massive, so perfectly preserved, that geologists have spent decades arguing about how they got there. And the answer they keep landing on is one that rewrites everything you thought you knew about this landscape. But before we get into what is actually under the sand, you need to understand what salt beds mean. Real deserts do not have them. Not like this. Salt accumulates in one way, and one way only, at this scale. It needs water, enormous amounts of water, sustained water, the kind of water that sits for centuries and then evaporates slowly, leaving behind a crystalline record of everything it once was. The Sahara has those records, hundreds of feet of them, which means the Sahara was once something else entirely. If that question pulls at something in you, stay with me, because the mainstream explanation for how this happened is about to run into some problems it cannot answer. And the alternative explanation, the one that the academic world has spent considerable energy dismissing, is going to make a great deal more sense by the time we are done. Subscribe if you are new here. This channel goes where the evidence goes, not where the textbooks tell us to stop. The standard geological story of the Sahara goes something like this. The region has cycled between wet and dry periods for millions of years, driven by shifts in Earth's orbital tilt and axial wobble, a process called the Milankovitch cycles. During wet periods, known as African humid periods, rainfall increased dramatically. Lakes formed, rivers ran, and the landscape supported vegetation and animal life. Then the cycle shifted, the rains retreated, and the desert returned. The salt beds, according to this framework, are relics of those ancient lake systems. Shallow inland seas evaporated. The salt stayed behind. That explanation works on the surface. It is tidy. It fits inside the accepted timeline. But when you start asking specific questions about the salt itself, the answer begins to fall apart. The first problem, not composition of the salt. The Saharan salt deposits are not just sodium chloride, plain table salt. They contain the full mineral signature of seawater. Magnesium chloride, calcium sulfate, potassium chloride, bromine compounds. This is not the residue of a freshwater lake that dried up. This is the chemical fingerprint of an ocean. When researchers test the isotopic ratios inside the Saharan salt formations, they find a match with marine evaporite sequences, meaning salt that formed from seawater, not from inland rainfall collecting in basins. Inland freshwater lakes produce a different salt signature. The chemistry is not the same. Rivers carry a particular mineral load from the rock they travel over. That mineral load does not match what is inside the Saharan deposits. What is inside those deposits matches an ocean. So now we have a different question. Not how did a lake evaporate over the Sahara, but how did an ocean get over the Sahara, and what happened to it? The conventional answer reaches for deep time. It says the Tethys Sea, the ancient ocean that preceded the Mediterranean, once covered parts of North Africa, and these deposits are its remnants from tens of millions of years ago. That story sounds authoritative. But the depth and preservation of those deposits creates a problem the conventional story does not solve cleanly. Salt is not a stable mineral when it comes to groundwater contact. It dissolves, it migrates. Over millions of years, subsurface water movement should have redistributed, diluted, or removed significant portions of these formations. The fact that they exist in coherent, layered, stratigraphically intact beds in some regions of the Sahara suggests that either the dissolution process has been far slower than expected, or the deposits are far younger than claimed. Younger than claimed. That phrase is worth sitting with, because it is where this investigation starts to become interesting. There are researchers within the alternative history and forbidden archaeology communities who have been making a specific argument for the last several decades. They argue that within the historical record, meaning within the last few thousand years rather than the last few million, large portions of what is now desert was covered by water, not metaphorically, not in terms of slightly higher rainfall, covered, submerged. And the evidence they point to is not just the salt. The salt is actually the least of it. The salt is where mainstream geology has already, reluctantly, confirmed that something unusual happened here. The salt is almost too obvious to argue about. The more interesting evidence is what is sitting on top of the sand. There is an extensive network of ancient riverbeds across the Sahara. They are called paleochannels, and they are visible from satellite imagery with extraordinary clarity. These are not small seasonal streams. These are the beds of what were once massive river systems, wide enough and deep enough to dwarf anything currently flowing in North Africa. The Sahara contains the dried remnants of rivers that, during their active periods, would have ranked among the largest on Earth. Mainstream science acknowledges these channels. They fit the African humid period narrative. During the Green Sahara, rivers ran. Then they stopped. Fine. But here is the detail that does not fit neatly. Some of these river channels cut through terrain that would require a sustained and powerful water source at elevations that do not make geographic sense for a rain-fed system. The flow directions, the erosion patterns, the way the channels intersect and branch suggest in certain regions not a gentle increase in rainfall, but an active drainage event. Water moving across the landscape in massive, rapid, sustained volume. Drainage. That word is important, because drainage implies something draining. A body of water emptying. Independent researchers have noted for years that the Saharan Paleochannel network, when mapped comprehensively, behaves less like a rainfall-fed river system and more like the aftermath of a receding sea. The channels radiate outward from central low points. They deepen toward the coasts. The erosion signatures in certain formations suggest water velocity far beyond what annual rainfall, even dramatically increased annual rainfall, could produce. The forbidden history interpretation of this data is straightforward. The Sahara was underwater, not millions of years ago. Recently enough to leave a landscape that has not fully erased the evidence. Recently enough that the riverbeds have not filled in completely. Recently enough that the salt beds have not dissolved. Recently enough, some researchers argue, that human civilizations witnessed it, survived it, and recorded it. And this is where the conversation about Tartaria enters the frame. The Tartaria hypothesis, for those unfamiliar, is a sprawling and contested body of alternative historical research that proposes the existence of a large and technologically sophisticated civilization, or network of civilizations, that existed prior to the history we are taught. The word Tartaria comes from old European and Russian maps, where a vast region of Central Eurasia was labeled as such. Over time, within the alternative history community, the concept of Tartaria has expanded to describe something larger. A global civilization, or at minimum a global cultural network, that was erased or reset within the last several hundred to several thousand years. The mechanisms proposed for this reset vary. Some researchers focus on a mud flood event, a sudden deposition of sediment that buried cities and reset populations. Others focus on a plasma event, an electromagnetic catastrophe that restructured geography. Others point to the evidence of a global ocean, a catastrophic flood not in the biblical metaphorical sense but in the literal geological sense, that covered significant portions of the landmass we now live on, drowned whatever civilization was operating there, and then receded, leaving behind salt, dried channels, and a confused archaeological record. The Saharan evidence speaks most directly to the third scenario. And the Saharan evidence is where the Tartaria framework is at its most empirically grounded, because unlike some of the more speculative claims within alternative history research, the salt beds of the Sahara are not contested. They exist. Their marine chemical composition is not entirely dismissed. The Paleochannel network is visible to anyone with a satellite image. What is contested is the interpretation. And interpretation is where the gatekeeping happens. Let us talk about the Chott el Djerid. It is a salt lake in southern Tunisia, the largest in the Sahara, and during the dry season it becomes an enormous salt flat, blindingly white, cracked into geometric patterns by the evaporation process. Beneath the visible surface salt, the sediment record extends downward through layers of evaporite deposits that paint a detailed picture of repeated inundation cycles. The chemical analysis of these layers shows alternating marine and freshwater signatures, which means the area was hit by seawater at multiple points, not just rainfall. The marine intrusion hypothesis for Chott el Djerid and the broader network of chotts across North Africa is an acknowledged geological discussion. Researchers debate whether the Mediterranean periodically extended southward through low-lying corridors during certain periods, flooding interior basins. That debate is real and ongoing. What is remarkable about the Tartaria-adjacent interpretation of this data is not that it invents evidence. It is that it takes the existing evidence and pushes the chronology forward. What if the marine intrusion was not a slow, gradual event driven by tectonic shifts over thousands of years? What if it was sudden? What if it happened fast enough to leave a coherent, relatively undisturbed evaporite sequence, rather than the mixed and partially dissolved record you would expect from millions of years of exposure? Fast inundation followed by relatively rapid retreat would produce exactly the kind of salt deposit record that geologists actually find: thick, layered, intact, marine in composition, sitting in a desert where it should not exist. The geological establishment answers this with an appeal to the deep timeline. It happened slowly, long ago. The preservation is a function of the extremely arid conditions of the modern Sahara, which slowed the dissolution process. This is not an unreasonable answer, but it depends on the assumption that the arid conditions have been consistently present for millions of years, and that assumption is itself contested by the evidence of the green Sahara periods, which indicate the region has been far less arid than currently for significant stretches of relatively recent history. If the Sahara was significantly wetter in the recent past, then the assumption that its arid conditions have preserved ancient evaporite deposits becomes weaker. Wetter conditions mean more subsurface water. More subsurface water means more dissolution. The paradox is that the mainstream story requires ancient deposits to be preserved by conditions that the mainstream story also says did not always exist. The alternative interpretation sidesteps this paradox by simply compressing the timeline. The deposits are younger. They are not as exposed to dissolution cycles as the mainstream timeline requires. They are intact because they have not been here as long as claimed. Younger deposits mean a more recent event. A more recent event means something our civilization should theoretically have some record of, and this is where the ancient textual sources enter the picture. The ancient world was full of flood narratives. This is not a fringe observation. Comparative mythology and religious studies have documented flood traditions on every inhabited continent. The standard interpretation is that these are all local flood events that got elevated to cosmic significance in the retelling, or that they all refer to the same event, typically identified with a deglaciation pulse at the end of the last ice age, around 12,000 years ago. But there is a third interpretation that the Tartaria research community has explored extensively. What if some of these narratives are describing a different event, more recent than the deglaciation pulse, and regional in scope but large enough to restructure entire civilizations? The Egyptian record is particularly interesting in this context. Ancient Egypt presents a known archaeological paradox. Its earliest dynasties appear fully formed, with sophisticated administrative systems, monumental architecture, and refined artistic traditions, with very little visible developmental period leading up to them. The standard explanation is that the pre-dynastic period, which we have only fragmentary archaeological evidence for, contained the developmental arc. But the fragmentary nature of the pre-dynastic record is itself suspicious. Where is the evidence of the slow build? Why does the archaeological record appear to begin almost midstream? One answer that the alternative history community has explored is that a catastrophic event reset the archaeological record. That whatever came before the dynastic period in Egypt was not a primitive pre-civilization, but a sophisticated one that was disrupted, partially destroyed, and rebuilt by survivors who carried knowledge forward but lost the physical infrastructure. The salt deposits of the surrounding region, the paleochannels that drain toward the Nile Valley, the lacustrine sediments found in areas that are now deep desert, all contribute to a picture of a landscape that was dramatically different in ways that could have included a large-scale inundation event. The Great Sphinx presents one of the most famous pieces of this argument, though it operates adjacent to the salt deposit question rather than directly within it. The Sphinx enclosure shows patterns of weathering that geologist Robert Schoch argued, controversially, were produced by extended water erosion rather than the wind and sand erosion typical of the desert environment. If Schoch is correct, the Sphinx is significantly older than conventionally dated, or it was exposed to large-scale water contact at a period when the Sahara was much wetter than today. Either interpretation requires a dramatic rethinking of the timeline of human civilization in the region. This is not fringe speculation for the sake of spectacle. The weathering patterns on the Sphinx enclosure are visible. Egyptologists dispute their cause. Geologists dispute their cause. The dispute itself tells you something important, which is that the evidence does not cleanly confirm the conventional story. Now bring the salt back in. You have a desert sitting on top of marine composition evaporite deposits hundreds of feet thick in some locations. You have paleochannel networks that behave like drainage systems for a receding body of water rather than simple rainfall accumulation. You have ancient lake beds that carry both fresh water and marine chemical signatures in their sediment layers. You have a civilization, Egypt, that appears with minimal archaeological developmental period. You have weathering patterns on ancient monuments that suggest water contact, and you have a global tradition of catastrophic flood memory across every major ancient culture. Each of these data points can be explained individually within the mainstream framework. Taken together, the mainstream framework requires an increasingly complicated series of independent explanations, each of which carries its own uncertainties. The alternative framework, that a large-scale water event struck the region within a historically proximate period, explains all of them with a single mechanism. Occam's razor is not a proof. The simpler explanation is not automatically the correct one. But it is worth noting that the mainstream narrative has accumulated so many independent special pleadings to explain so many pieces of the same picture that the simplicity it originally offered is largely an illusion at this point. Let us move to the question of what the Tartaria framework actually proposes about the mechanism of the Saharan submersion, because this is where the research community is most divided and where the claims become most extraordinary. One school of thought within alternative history focuses on the polar ice cap model. The idea is that a significant portion of polar ice, either from the Antarctic ice sheet or from remnants of the last glacial maximum ice sheets, underwent rapid collapse, producing a pulse of meltwater large enough to temporarily elevate global sea levels far beyond current levels and to push seawater into low-lying continental interiors. The Sahara, large portions of which sit at relatively low elevation, particularly in the central and northern regions, would have been vulnerable to exactly this kind of marine intrusion. This is not entirely disconnected from mainstream geology. The meltwater pulse 1A event, which occurred approximately 14,000 years ago, is estimated to have raised global sea levels by somewhere between 12 and 22 meters in a geologically short period. That is a real event with real documentation. The argument within the alternative history community is that similar pulses may have occurred more recently at smaller scales, or that the mainstream estimate of meltwater pulse 1A's magnitude is significantly understated. A second school of thought invokes extraterrestrial impact or plasma discharge events. This is more speculative, but it draws on real research. The Younger Dryas impact hypothesis, which proposes that a comet or asteroid fragmented over the North American ice sheet around 12,000 years ago, triggering the Younger Dryas cooling event, has been a legitimate and contested scientific debate for the last 2 decades. Researchers have found nanodiamonds, platinum group metals, and shocked quartz in a layer at the Younger Dryas boundary at sites across 3 continents. These are markers associated with impact events. The mainstream scientific community remains divided on the interpretation. The Tartaria research community takes the impact hypothesis further and suggests that the recorded flood events in ancient texts correspond to the aftermath of an impact event large enough to disrupt ocean circulation, drive temporary sea level changes through impact-generated tsunamis, and destabilize coastal and interior civilizations simultaneously. The Saharan salt deposits, in this framework, are evidence of a tsunami or series of tsunamis with continental reach, or of a temporary marine inundation driven by impact-related processes that have no clean analogue in the conventional geological record. A third explanation, the one most distinctly associated with Tartaria research rather than adjacent scientific debates, involves the idea of a different distribution of landmass and water in the relatively recent past. This is the most contested position. It proposes that the geography of the Earth was more dramatically different in the last few thousand years than mainstream geology allows, that continental positions, ocean coverage, and the relationship between land and sea have undergone changes faster than the accepted plate tectonic timeline permits. This position is difficult to defend within conventional geological frameworks, and most researchers in the alternative history community acknowledge that, but they point to the speed at which geological consensus has shifted on other questions. Plate tectonics itself was a radical proposition when Alfred Wegener first proposed continental drift in 1912. He was ridiculed by the geological establishment for decades. The theory was not accepted until mid-century, when ocean floor mapping provided overwhelming evidence. The lesson the alternative history community argues is not that mainstream geology is always right. It is that paradigm shifts happen, they take time, and the evidence often precedes the acceptance by generations. The salt deposits of the Sahara are, in this reading, not evidence that the mainstream is completely wrong about everything. They are evidence that a specific question, how did marine composition evaporite deposits of this scale end up in the middle of the largest desert on Earth, does not have a fully satisfying answer within the current framework. And unsatisfying answers to specific questions are often the cracks through which new paradigms eventually enter. Let us shift from the geological argument to the cartographic one, because the cartographic evidence for a different recent Sahara is, in some ways, more immediately striking than the chemistry of salt deposits. Old maps are dangerous territory in alternative history research because they attract both genuine analysis and motivated interpretation. With that caveat acknowledged, there are specific cartographic anomalies in historical maps of North Africa that raise legitimate questions. Medieval and early modern European maps of the African interior, drawn from the accounts of Arab geographers, traders, and explorers, frequently depict large interior lakes and rivers in regions that are now completely arid. Some of this can be attributed to confusion, exaggeration, or the conflation of distant reports. But the consistency with which large interior water bodies appear in maps from multiple independent cartographic traditions is worth noting. The Arab geographer Muhammad al-Idrisi, working in the 12th century, produced maps of Africa that showed extensive river systems and interior lakes in the Saharan region. Al-Idrisi was not an amateur. He was a sophisticated scholar who compiled his geographic work from the accounts of travelers and merchants across the Islamic world. His maps are not fantasy documents. They reflect real geographic knowledge gathered from real sources. The question is whether those sources were describing conditions that existed in the 12th century or were transmitting older geographic knowledge from periods when the Saharan interior actually did contain significant water bodies. The African humid period, which mainstream science dates to roughly 5,000 to 10,000 years ago, would predate al-Idrisi by a wide margin. But some of the water bodies he depicts are so consistent with the locations of known paleolakes in the Sahara that they suggest either a direct transmission of knowledge from populations that remembered the humid period, or evidence that conditions were wetter in the Saharan interior more recently than mainstream science acknowledges. This is speculative, but it is not invented. The maps exist, the paleolake locations are confirmed, the correspondence between them is real. The interpretation of that correspondence is where legitimate debate exists. The Ptolemy maps of Africa present a similar situation. Claudius Ptolemy, the 2nd century Greek geographer, depicted in his geography a mountain range in the interior of Africa that he called the Mountains of the Moon, which he identified as the source of the Nile. For centuries, this was dismissed as myth. Then, European explorers in the 19th century discovered that the Ruwenzori mountain range in Central Africa, which was entirely unknown to them before then, corresponded remarkably closely to the position and description Ptolemy had given. Ptolemy's geographic knowledge of interior Africa was apparently more accurate than centuries of dismissal had suggested. If Ptolemy had reliable knowledge of Central African geography that was vindicated by later discovery, what other elements of his African geography might be reliable descriptions of conditions that no longer exist? The water bodies and river systems he depicted in North Africa do not match current conditions. They match, to a significant degree, the Paleo-Channel and Paleo-Lake record that geologists have reconstructed. That is not proof of anything, but it is a pattern that deserves attention rather than dismissal. Now we come to the human populations of the Sahara, because salt and maps are abstract, the people are concrete. There is a genetic and linguistic puzzle in North Africa that the conventional narrative handles awkwardly. The Tuareg people, who have historically inhabited the Central Sahara, are one of the most genetically and linguistically isolated populations on Earth. Their language, Tamashek, belongs to the Berber family, but is archaic in ways that suggest extreme isolation. Their genetic profile contains markers that link them to populations that should not, within the conventional migration framework, be related to them at all. More striking is their oral tradition. The Tuareg maintain stories of ancestors who lived in a Sahara of rivers and lakes, who watched the water recede over generations, and who adapted their civilization from a water-rich to a water-poor environment. Mainstream anthropology categorizes these stories as distant memories of the African humid period, transmitted through thousands of years of oral tradition. This is possible. But oral traditions across cultures typically do not preserve geographic detail with precision over 10,000 years. They preserve it well over hundreds of years, sometimes over a few thousand at the outside. If the Tuareg oral tradition is a genuine cultural memory rather than mythological reconstruction, it suggests the Saharan water receded within a time frame that oral tradition can plausibly preserve, which puts the most recent large-scale water coverage of the Sahara within the historical rather than the geological timeline. The Garamantes civilization, which flourished in the Fezzan region of what is now southwestern Libya from roughly 900 BCE to 700 CE, built an extraordinary underground water system called the Foggara. These were hand-dug tunnels, some of them extending for kilometers, that tapped into a deep aquifer system beneath the desert to bring water to the surface for agriculture. The Garamantes managed to maintain a sophisticated agricultural civilization in the middle of the Sahara for over 1,000 years using this technology. The aquifer system they tapped is now known as the Nubian Sandstone Aquifer System, one of the largest known fossil water reserves on Earth. It contains an estimated 150,000 cubic kilometers of water, most of which is radiocarbon dated to between 75,000 and 100,000 years old. This is ancient water, trapped from a period of high rainfall in the deep past. But here is the detail that the Tartaria-adjacent researchers have noted. Fossil water does not always stay put. It can be replenished, slowly, by surface infiltration events. And the sheer volume of the Nubian aquifer, the depth at which it sits, the pressure that maintains it, all suggest that at some point it was recharged by something more than gradual rainfall percolation. The chemistry of the water, which, like the surface salt deposits, carries traces of marine influence in some analyses, hints that part of its composition may trace back to a marine inundation event rather than purely to rainfall accumulation. This is highly speculative, and the mainstream view of the Nubian aquifer does not require marine input. But the question has been asked by researchers outside the mainstream, and it has not been definitively closed. Let us bring the threads together by returning to the specific claim in the title of this video. The Sahara has sea salt deposits, hundreds of feet thick. Real deserts do not have salt beds like this. The second part of that statement requires clarification, because it is slightly more nuanced than a flat assertion. Real deserts can have salt deposits. The Atacama Desert in South America has significant salt formations. The Gobi has them. Various desert salt flats exist worldwide. What makes the Saharan deposits unusual is not the mere existence of salt, but the combination of several factors. The scale and depth of the formations, the marine, rather than freshwater chemical composition, the distribution across a region that shows geological evidence of a complex water history, including both inland lake systems and potential marine contact, and the relative preservation of those deposits in a landscape that should, over the timescale of mainstream geological dating, have experienced significant dissolution and redistribution. The conventional explanation is internally consistent if you accept its assumptions. The alternative explanation is internally consistent if you accept different assumptions about the timeline. What neither explanation can do is pretend the salt is not there, pretend its composition is not marine in character, or pretend the paleo-channel network does not look like drainage rather than accumulation. The Tartaria framework, as it applies to the Saharan evidence, does not require you to accept any single, speculative mechanism for the inundation. It does not require you to believe in a specific lost civilization, in any particular catastrophe scenario, or in any of the more contested claims within the broader alternative history community. It requires only one acknowledgement, that the physical evidence in the Sahara is consistent with a large-scale water event that occurred more recently than the mainstream geological timeline comfortably allows, that this event may have been rapid rather than gradual, and that its timing overlaps with the period during which complex human civilizations were developing across the ancient world. If that is true, then the history of human civilization is missing a chapter, not a metaphorical missing chapter, a literal one. The period before the reset, before the water, before whatever catastrophe reshaped the Sahara and left a desert sitting on an ocean floor. Who was there? What did they build? What did they know? The salt does not tell us that, but it tells us that something was there. Something was covered. Something ended. And the sand that now blows across the dunes of the world's largest hot desert is blowing across a graveyard of a world that the official history has not yet learned to mourn. The evidence is in the ground, hundreds of feet of it, marine chemistry in a desert, channels that drain a sea that is not there, lakes that dried before memory and then somehow left a mark on memory anyway. Something happened here. The salt remembers. The question is whether we are willing to follow the evidence to wherever it leads, even if that destination requires us to fundamentally rethink what we know about the past. The researchers who are willing to ask these questions are doing real work. They are looking at real data. They are reaching conclusions that the mainstream finds uncomfortable, which is not the same as saying those conclusions are wrong. Every paradigm shift in the history of science looked uncomfortable before the evidence became undeniable. The Sahara's salt beds may be that kind of evidence, not proof of any specific alternative history, but proof that the story we have been told is incomplete in ways that matter. Proof that beneath the desert, beneath the narrative, beneath the comfortable timeline, something deeper is waiting. And finding it is going to require people who are not afraid to look. If this kind of investigation resonates with you, there is more where this came from. The channel covers the edges of the official record, the places where the evidence and the explanation do not quite match, the anomalies that get buried not in sand, but in academic silence. Subscribe so you are here for the next one. Share this with someone who asks real questions. And if you want to go deeper on the Tartaria framework and the evidence that has built the case for a reset civilization, the next video is on screen now. The desert keeps its secrets for a long time, but not forever.